Welcome back, everyone. We hope you're enjoying the event so far and you got some time to check out the showcases in the other room. Back to our exciting program. So we have an awesome panel on on-chain and off-chain interoperability powered by ZK Technologies. And for this one, we're going to shift gears a little bit from talking about layer 1, layer 2 interoperability to how we're connecting off-chain data and off-chain devices to on-chain resources. So with that, I'd like to introduce to the stage our panelists for today. Kartin Wong, co-founder at Hyper Oracle. Mo Dong, co-founder at Celer. Sinka Gao, founder of DelphinusLab and ZK Sync, and Bo Yu, co-founder of Topia. And today's session will be moderated by Celer Biasco from IoTeX. Let's give everybody a hand.
All right. Thanks so much, Larry, for the introduction. And thank you to our awesome panelists for being up here today. I think I'm personally really excited about this panel. I think ZK and middleware infra in general is one of the hottest and most talked about technologies right now in the Web3 space. But something that I wanted to talk about is, it's a very technical concept. Sometimes the average investor or the average user may not understand off the bat what these technologies are, right? So whether it be data availability, whether it be ZK rollups, modularity, I think what I want to start with is a question for you to answer for our non-technical audience. So can you explain kind of from each of your perspectives, very simply, what this technology is and why would it matter for a retail investor or user?
You mean the ZK technology? Yeah, so I think ZK technology is important for retail user. Like first, because it's privacy. Because we know like the blockchain technology is like a good technology that for normal people to leverage on to preserve their own right on the cyber era. And so privacy definitely is the biggest one for ZK technology. And then the second one is like the massive adoption for blockchain. First, we can use ZKP to do the roll up. And also we can use ZKP to do Oracle. And so with this new innovation and application implementation of zero knowledge proof, normal people can actually to use the blockchain technology in their real life now. No matter from pay the stuff for what they try to buy by using a ZK rollup, or like submit a data from the what they saw from the sensor to a smart contract, or they want the smart contract to do some kind of computation for them and convert that into some on-chain financial asset. And then I think all of this application will be really important for normal people nowadays.
Yeah. Well, Kartin gave a very great summary, I would say. Maybe I would just dive a little bit deeper into this slightly, in the sense that first of all, privacy is a great property that brought by ZK, and the second property, the technology behind its contribution to mass adoption of blockchain is a property called computation migration. Right. So like basically, what does computation migration mean? Is that this is basically the piece of property that many of the ZK rollups, ZK Pro processors are built based on, right? So basically what computation migration is talking about is that we now have a blockchain that is the Web3 CPU, kind of, and you can do all sorts of computation on it. But unfortunately, that piece of CPU has some limitations in terms of it is very bad at heavy and data-rich computations. But what you can do with ZK is that you can actually migrate that computation that you originally have to do on-chain to an off-chain environment with very low unit cost and very low latency. And you do the computation in the off-chain environment, but in addition to the computation itself, you also generate a magical cryptographic proof, which is a ZK proof. And you bring these two things together and put it on-chain. And in the on-chain computation world, you just need to do a very simple verification of the computation and verification of the ZK proof. And you're effectively migrated the computation from a very high unit cost environment to very low unit cost environment, even though that the total computation unit increased pretty significantly. But because of the kind of a difference of the computation environment, you actually get much cheaper and much faster overall computation results. So this is the premises, and this is the intuition behind a lot of these ZK rollup work, and also like generally ZK coprocessors like what we are doing recently.
Yeah, that's awesome. I love that you call it kind of the magical proof too, right? Where a lot of the users don't realize what's happening behind the scenes, but like you said, what they care about is the cheaper, the faster, the better solutions. Bo, I kind of want to hear your perspective on how data availability fits into this too before we kind of dive back into the ZK side of things.
Yeah, sure. Yeah, so the data availability, the DA idea is actually coming from the Ethereum ecosystem, and then so the two-word data availability itself is actually not that easy to understand. Also, there's recent trends among community trying to explain these words more clearly. So I would like to break down for DA into data publishing and data storage. So basically in Ethereum, we all the transaction data and proofs from layer 2s have to be posted on layer 1, which is Ethereum, for them be able to make to become layer 2s. So basically, DA is the kind of the block space that store all those kind of transaction data from layer 2s that make sure that all the things running on the layer 2s are valid. Yeah, so that's what a DA is, and then it's kind of like a core piece in the rollup centric roadmap in Ethereum. Yeah.
That's awesome. And Sinka, over to you. How do you think the definitions of these all fit together, and how does your project simply explain these technologies to a non-technical audience?
Okay, I'm actually not a DA expert, so to me that DA is, so I mean, there's a minimal set of data that you need to actually replay and verify successful execution of state transform in blockchain, right? So that minimal set of data is a must data set that you have to provide. And I think the data availability means the availability of this particular set of data. For the CK side, I think I might just add in two features. The first feature is the trustless. That means you can trust the calculation without actually redo the calculation. But there's always a way to actually check the calculation by just recalculate the calculation, right? So that means we didn't need another attribute, which is succinct. That means you can check the calculation without redo the calculation within amount of time that is much less comparing to redo the calculation. Thanks.
Yeah, that's awesome. Thank you for your thoughts on that. Kind of want to dive into ZKs a little deeper here, specifically the speeds, and kind of take a state of the nation question on where ZKs are at right now. So we hear this magical number, right, that 20,000 transactions can be condensed into one Ethereum block. That's kind of, when people explain it very simply, that's what we're either targeting towards, that's the journey we're trying to get to. What I'd like to understand from you guys is, what about your projects right now? What are your current speeds at? What are your current projections of how much faster you think it can get, and where do you see this journey kind of taking your project in terms of speed and the ambitions for that?
Yeah, so for Hyper Oracle, we utilize the ZK version from DelphinusLab, right, obviously. So, but beside that, we also need to have like the attestation circuit and some another output from like different DE pin or like a sensor from like internet data, right? You need to batch them together. And right now, the speed actually is like barely usable. And it's okay level. We can use it for your product. And right now we have like the ZK Oracle in Sephora testnet. And I think we can catch up the block time for Ethereum, which is like 12 seconds. The majority of the computation tasks right now in ZK Oracle. But anything more than faster than Ethereum, I think it still take a while for us to be able to support that every block. Yeah.
So yeah, I think I guess like the entire ZK community should first of all definitely celebrate the significant progress over the last couple of years. We have seen a lot of new things coming out, even just like very recently, like the structured lookup things like Lasso, and previously folding, based scheme like Nova, Supernova. These things were just not there just 3 years ago. So like even 3 years ago, people were still talking about whether implementing ZK EVM or any sort of a ZK VM is like even possible. But today, folks like a lot of ZK rollups and of course DelphinusLabs are already tackling very hard problem of general computing using ZK. So it's very impressive. And the way we look at this is that ZK's kind of general computing is one avenue of kind of a ZK development and a ZK kind of a technology. But we're also looking at specific kind of circuits and specific use cases for ZK. For example, for ZK co-processing, right? So just like your CPU is not good at certain kind of a calculation and need assistance from GPU for kind of visual related tasks, the Web3 CPU as blockchain also needed ZK coprocessor to process certain kind of a data rich and computation heavy tasks. And for these data rich and computation heavy tasks, with the existing development of ZK today, you can actually already achieve very large scale computation on them. For example, you can prove over very long time horizon a particular user's trading volume on Uniswap in under 30 seconds in our case. So these kind of things are becoming possible, and we're very excited to kind of incorporate new things like folding and stuff like that into the technology stack. And I think like this applies to every team in the ZK space for sure.
Sinka, over to you.
Hi. So I think regarding the benchmark of ZK virtual machine, which is our area, there are some very outstanding virtual machines there. Like there's a virtual machine called the Polygon Maiden, right? It actually has reached 2 to the 20 instructions in 12 seconds in CPU with a simplex instruction set. We reached about 2 to the 16 instruction per second on a GPU, which is much slower, but we have 140 instructions in our instruction set. So when we're actually comparing with the speed of ZK solutions, is that we will probably, especially in ZK VM, we're comparing the instruction per second and divides the total instruction numbers, right? And for example, if we check the RISC-0, which is a very popular project these days, they actually reached 2 to the 17 to 2 to the 18 instruction per set with instruction set of 47 instructions for RISC-V. And there's another metric that you can access, you can measure the performance of ZK VM, that when talking about ZK EVMs, they're talking about the transactions per second. But as long as I know, currently there's no explicit benchmark for each ZK EVM that reports their TPS at the moment for a single CPU for a single GPU or for a standard CPU parallel machine. Yeah, that's all I know. Thanks.
Yeah.
Yeah. So adding a little quick thing here, because I'm not ZK expert, but I'm looking from the market perspective, and also especially our clients. So many of our clients actually are ZK rollup, and also the ZK rollup as a service. So as I saw kind of saw the trends of actually many of them are actually moving to the testnet and gradually to the mainnet phase. So I would say probably it's kind of on the dawn of actually many of the ZK rollups are coming out. Yeah.
That's awesome, thank you. Yeah, I think it's interesting to hear each of your perspectives on this. But Mo, I kind of want to start with you on this next question here, because I like how you talked about the fact that even though things are still slow and things are still early, this wasn't even possible a couple years ago. And I think acknowledging where we are with ZKs right now and middleware in general, right, where we can look at any new technology and acknowledge that startup costs are typically very high. Initially, it's going to be a lot more expensive at the start compared to when you really get things rolling. And I would say that is one of the biggest challenges and talked about problems right now is initial costs for ZK solutions right now. So kind of want to hear from each of you right now. What are you doing to make your project the most business-friendly and cost-effective solution it can be? And what does your projection look like for that?
Yeah, sure. I mean, I think if we're looking at, just for ZK technology in general, right? So we look at ZK rollups. If we just compare costs between ZK rollups and optimistic rollups, ZK rollups are generally still more expensive, even if they're just barely covering their sequencing and proving cost today, right? So this is like the state of ZK in general. But there are a lot of ways that people are working towards to improve the efficiency of various different stacks, right? So from the lowest layer, there is like a parallel processing and very smart batching, batching frameworks and batching architectures you can employ in your stack, and things like, for example, for ZK co-processing in our case, you usually need to prove very similar structured proofs or very similar structured computations, and you can leverage that by significantly reduce the computation cost you need to generate proofs. And we have seen amazing result by incorporating some of the most recent development in the technology space for that. And on top of the underlying technology, there is how you present the ZK development framework to the developers, right? So developers generally don't want to just write circuits, of course. They want to deal with a higher level construct, right? So if, let's say, some developer want to build a user retention and user engagement functionality in their application and want to use ZK, then they better have a very easy to access, either easy to access API or easy to access DSL, so they can easily incorporate that into their existing application stack. So this is why we're at Brevis and Celer, we're building out a very friendly DSL layer so that a user can actually interact easily with the data they want to query and data they want to incorporate in the smart contract stack directly, and we feel that is also quite important aside from the technology side of things.
Yeah, good intro. Yeah, I just want to continue from that, how to let people to use the ZK dApp, right? We need to make it as easy as possible for developer to develop a ZK dApp today, right? As we know, making a circuit from the scratch is even you are a math PhD, it still takes you a few months to do it. So right now with the power of ZKVM, we can basically and some tooling, compiler and a ZK version for whatever language, for Python, Java, whatever. And then once developer can develop this ZK dApp easily, if you make the whole ecosystem become more powerful than ever before, and because we can have more computation and more data source for the smart contract, and I think that will bring us to the next era for the smart contract. That smart contract is smarter and faster.
Yeah, that's awesome. I think the smarter and faster definitely sums it up well. And Sinka, what about you? How do you think making it the most business-friendly option?
I'm actually doing a tooling thing, right? So my way of actually onboarding customers is that way. We try to understand the customer needs and what are their obstacles or barriers that to onboarding in our ZKVM, and try to solve the problem case by case currently at the moment. Thanks.
That's awesome. And Bo, from data availability, kind of similar, different?
Yeah, so basically to reduce the cost of overall ZK rollup, we're actually attacking the problem from a different angle from that. So one fact is actually even for ZK rollup, the overall cost of that is actually, I think, more than 80 or 85 or even 90% of the cost is actually from DA, not from ZK. So that we're actually talking from another space. So we're kind of building the solution like the mini dank sharding, which we will have like a last Ethereum validator to substantially reduce the DA costs. And then so although there are indeed some kind of so-called weaker security assumptions, but that's kind of much higher than many of the existing solutions. So basically, we can reduce the currently like 80 or 90% of the overall ZK rollup cost by like maybe 50 or even 60%. And then so we are targeted to the various distribution of the market. So probably the most, the projects looking for the safest solution, we're still looking for Ethereum DA. But for other use cases like the on-chain gaming, the social fi or the NFTs where their data is not that valuable, you don't need billions to secure data for the on-chain game, right? So we're actually targeting for them to make sure that we can offer a low cost but still decentralized ZK rollup solution to actually drive more adoption of various blockchain use cases. Yeah, that's our approach from the DA side.
Yeah, may I have a question for you?
Sure, yeah.
Do you prefer like the turn of DA or the DP? Data publishing, okay.
Yeah, it's a great question. Actually, the data publishing was actually come from my friend Bartek, who's actually the founder of L2Beat. And then so this is actually a very good point because data publishing actually describe more about what DA really does, right? But we have kind of I just had the conversation with him last night, and then we kind of make the prediction in our Telegram chat. He says basically overall the community will gradually move DA equals to data publishing plus data storage. So like DA will overall evolve to that. So it will include both data publishing and the mid to long-term storage. It's a great question. Yeah, we probably will see more data publishing in future. Yeah.
That's awesome. Love that. Thank you. And I think, hearing your perspective too about security versus cost, I think is helpful for a general audience to understand too. So I love that. Thank you. Next thing I want to talk about, I actually want to talk about a quote here and kind of get your thoughts, whether you agree, disagree, some insights to it. So Anthony Rose of ZK Sync had a great statement recently where he said, in the future, no one will think about which ZK rollup they are on because it'll all just be infrastructure. I think that if we don't get into that world, then we've probably failed. It's the same way as somebody using Snapchat or Facebook doesn't really have to know about TCP or HTTP. It's just the plumbing of the way the internet works. Agree, disagree, expanding on that. Would love to hear each of your thoughts.
Yeah, I think this is a really good saying because in this imagination, we basically merge the blockchain technology in our life, right? So nobody care how the light bulb is working, how many voltage in the light bulb at this moment, right? You just use it. And then, so I think it's a really good description, so I agree with him. And so also there's another good feature for blockchain is the decentralization. Decentralization means nobody take controls, right? So which means everybody can participate and become part of the network and become part of the protocol and do whatever they like. And so I think, with the growing of this technology and this space, more people come in and we'll mix up the whole population pool here and nobody no longer care about are you the fans of that protocol or that protocol? I think by the time growing, because everybody using the same thing, in the code level, it's supposed to be the same thing. Right? So it won't care about name is blah blah swap or cha cha cross swap, right? Does not matter. It's just that piece of the code you're using. And so I think it's a good thing to even it's a good future we are heading to with that image. Yeah.
That's awesome.
Yeah, I mean, that will be definitely the ideal world that we want to, push towards. But I'm just curious about all the friends here. How many years do you think we will kind of, how many years it will take until we actually get there? And
not too long, I guess.
Not too long.
Probably 10 years, I guess.
Okay.
Yeah.
Well,
Probably people in 10 years, like from now, they will find out this video. It's like, hey, this guy says like 10 years, but we are not there yet. But it's fine, right? People always wrong, sometimes right, sometimes wrong. But I think that 10 years is long enough for the world to validate the blockchain future.
Yeah, absolutely.
Yeah, I guess probably it all depends on the actually the app developer, not us, not our infrastructure provider. So basically, we have to kind of path the fire to them to actually build that. And then to circle back to the question, I think I agree with the part that we'll have kind of like hundreds or thousands of, whether it's a ZK rollup or optimistic rollup. But for the second part, I guess probably people would still be aware of which rollup it is, because first of all, it's for different ZK rollup, they have community and they have their bread and butter of what they're doing. Like some are kind of very good at a lot, like the DAX or the financial derivatives, and also some are really good at on-chain gaming. And so it's like it will be kind of different kinds of a vibe of the community. And also there are some kind of differences in features, like one rollup called Zero Gas. They're actually trying to provide some kind of for some of their key actions to be zero gas subsidized by the DApp provider. So like it's like a different use cases, different way to use it, and different communities. So probably we'll have tons of them, but people will still be aware, and there'll be some quite lots of cults among those stuff. Yeah, that's my take.
Yeah, I just want to add a little bit more on that. I think, I heard debates on this previously. Like, it really depends on whether you see these underlying infrastructures as plumbings and the kind of a water companies. You don't really care. Like, if you turn on the water faucet, you don't really care where the water is coming from. But if you think of these, just on top of your points here, if you think about these blockchains and community as network states, as kind of an equivalent of nation states, or equivalent of the city, then you have people living in the city. People are different. The things you can do in Singapore will be very different from the things you can do in Mountain View, in California, for example. So, it's really depends on like where kind of do you draw the analogy, right? So like, whether it's a nation state, a city analogy, or you're drawing the plumbing analogy. So I think it might be a mixture of both, in the sense that there will be differences in terms of like a major ecosystem there, and just like we're kind of in the stage where all the blockchains are just like stem cells, and the stem cells later, when they multiply, they will actually differentiate and turn into different organs, turn into different kind of functionalities, maybe in the future. But still, some cluster of stem cells are all going to coordinating into doing the same thing, like your lung, your hearts, and stuff like that. So, for example, for Ethereum, many layer 2s on Ethereum may actually kind of become its uncoordinated nation states in the Ethereum ecosystem, and you may not care which rollup you're actually on, but you may actually kind of care about like which blockchains you're on, because there are still going to be design differences, there are still going to be cultural differences and community differences between them. So that may be, one way to look at it.
That's really interesting. Yeah, I think the deeper you get into the analogy, the more complex it can be, right? We all kind of agree on the thing that maybe people won't care, 10 years from now, if that's the timeline. But I think a follow-up to that, today we've been talking about interoperability both in a technical sense, where panel 1 talked about cross-layer and cross-chain, where how are we collaborating between projects. But I'm curious to hear your guys' perspectives on how that applies to ZK, right? So maybe not from a technical side of right now how you're working together, but maybe from a collaboration research side. What kind of conversations are being had with that right now?
Yeah, so I think right now, like everything is going to be ZK, right? In blockchain at least. And so actually, if you want to do a cross-chain thing between layer 2 and between layer 1 blockchain, it's like completely different thing. So yeah, I would say like doing cross-chain between layer 2 is safer and faster and easier. But it's also important because we have multiple different layer 1 right now, right? So I think there's like we can basically generate bunch like a proof for different layer 2, and then have them communicate with each other through some zero-knowledge proof, and then send to different layer 2 and verify it. And the more verification you've done for that certain transaction behavior, the safer it will be, I guess. Because like people was talking about like adding the TE in the ZK rollup. And I was like, how about add OP and FHE in it too, right? It's like ultra rollup, we can call it. And and also I think there's another opportunity here. You can create a like liquidity layer between like the layer 2 and layer 1 because like you have like a withdrawal period, right? So you can also do that with like the zero knowledge proof to hold certain asset in the state that is not finalized in either layer 1 or layer 2, and then make it become a liquid state and floating between different layer 2. That I think will be like one of the major usage for this like state proofing in the future. Probably in this year, I guess.
So yeah, I mean, like on the interoperability side, on the technical point of view, like different ZK rollups need to be interoperated for assets and also for states. So Celer is providing that exact functionality. We have processed about $15 billion transaction volume across all our supported chains. Many of them are ZK, and the added benefit of using ZK in interoperability's context is that you can actually have more secure interoperability because all these different kind of ZK chains themselves has ZK proofs, and therefore you can actually run kind of a ZK-like clients between them relatively easily. So we're definitely looking forward to that future. Now, on the research front, there is a lot of research that need to be done in the space, and some of you guys are kind of championing and leading many of that. Like for example, DelphinusLab is doing great work, but I think we are at the point that kind of some alliance and a common initiative need to be built. For example, for folding, the folding is great. Everyone knows that. But like folding today is so far from actually kind of being practical on Ethereum because there's no KZG in folding. There's no kind of parallel processing in folding, and no one is actually intending to build it because if any single project build it, it becomes a common public good, and every other project use it, and kind of we fall into the traditive common issue. Right, so I was just talking with like Ethereum Foundation folks the other day, and we were thinking about kind of forming this alliance where multiple projects can contribute to the same cause in terms of public good, and in money contribution or in kind of a human personnel contribution, so they can build some common good that actually can be used by all the ZK project and benefit the entire community.
That's awesome, thanks. Yeah, wrapping up last couple minutes here. Sinka, want to hear your thoughts on interoperability in ZK?
Oh, okay, to keep it short, so currently the ZK technology contains 3 different components: the arithmetic gates, the proof scheme, and the tooling that are used as a key part of the proving scheme. So we are currently trying to make some breakthrough on the customer gates, the arithmetic part and the tooling part, but actually using others' proving scheme. Thanks.
So in terms of interoperability, actually, we're doing it from the DA side as well. So basically, we can consider like the DA is like a short-term database for all the rollups. So imagine rollup A, rollup B, rollup C, they're all connecting through our DA. Then they're actually connected to the same database. So we're actually, it's kind of it's also one of our key features to build a shared DA layer, which actually we are enable all these kind of cross rollup communication perfectly through the DA layer. No bridge, no hack, no, just purely from the DA, because DA is actually at the very end of a transaction life cycle. So we actually kind of avoided one of the many risks on doing the kind of the cross rollup transaction before that. So we're actually building the shared DA for the rollups through the DA layer, and it's one of the safer or the safest route that we have researched on. Yeah.
That's awesome. Yeah, thank you guys all. I feel like I've learned so much today. Hopefully the audience has learned a bunch too. I really appreciate your perspectives, your explanations, the analogies, everything. So thank you so much for being up here, and really appreciate talking about interoperability in the lens of ZK and middleware solutions.